guys, have either of you played with Storm yet?
No, I haven't.
No, I was just reading about it before the meetup.
I also have not. I, in a panic because I'm on a Windows machine, I was like, I wonder if it's going to run on my Windows machine. And so I got a version of it working in like 20 minutes before. So at least I know we won't be stumbling through how to install Clojure on Windows for the meetup. Let me share. So we can do. Sorry, where's the Zoom control? Sometimes get a little annoying. So let's see. I was wanting to try this. So if you just do, so this is the quick start for in the Flowstorm. So Flowstorm is a tracing debugger for Clojure and ClojureScript. Have either of you like used debuggers a lot, or are you like me where you basically print line debug a lot?
I tend to print line more
Yeah,
than
same.
Yeah.
I had a coworker a couple of jobs ago, and we were a Perl shop, and he would use the Perl debugger a lot. And I remember watching; it was like watching a magician, and it was very useful and made me want to learn. But I never quite got to it. Love to see. Maybe this will be enough to make me try this. Let me see. If I run this, require the API. Here, I'll put this into the Clojure chat too, so everyone can follow along. And then we'll see if this works, because I'm running it in my terminal is in WSL or like Windows Subsystem for Linux. And so it's going to pop something up, or it should. And I'm wondering if it's going to be able to do that because it might need an X or something. Yeah, nothing happened. Okay, so I'm going to go back to what I did before, which is the remote debugging. So remote debugging, you run this is now PowerShell. And so if you run the remote debugger, that comes up really quickly. So that's this one right here, start debugger. And then instead of saying local connect, it's remote connect. So let me try that on. Oops. I think if you're on a Mac, this probably would work directly. Are you both on Macs?
Yeah. I am. I'm trying it right now. I did not see. Oh, here, let me try this Artrix thing again. Not see the debugger window pop up. Huh.
All right. Look at that. Okay. So I just said remote connect. And now the debugger window. Did you do local connect and did the window come up there?
Yeah. Yeah, local connect didn't work. I'm just trying remote connect right now.
I also had to do this where I don't know if you can see on the left side here, I had to say remote connect because it's running on my, it's funny that running on the same computer, the remote is running on the same computer, but the local host inside of WSL is not the same as local host outside apparently. So I had to say connect to the other port, but I think if you're running it with both like two terminal windows on a Mac, it probably should be just work without the host and port. So let me see. Where was that instrument? Okay, here, rtrace. Where was the first one? Okay, here you go. There you go, rtrace, and there's a reduce here. We just run that and go back to Flowstorm. Hey, look at that. Well, we have something. Is it popped up for you? Lost you now.
Yeah, I'm still trying to figure this out. Is it so? Okay, let me try this.
What about you, Tyson? Have you gotten it work running?
No, I'm not trying to run it locally this time because I usually spend too much time trying to get it working and I have a hard time following along. So I've just been watching.
Oh, okay, cool.
Yeah.
Yeah, I might do the same. I think I've got a Java runtime problem. Maybe a version problem. But yeah, if you continue on, I might
so it's
just do the same and watch.
Clojure running. Okay, so I said, let's debug something. And yes, in my Flowstorm, it looks like what this one is. And also it's cool. It uses a dark theme by default. That's because my computer is on dark mode. After you running, you should get the return value of the expression. We do over here, 55. And the debugger should show the executed form. You can go ahead and use the stepping controls to step over the code. Okay, let's see. The stepping controls. So I'm guessing this is step. Okay. So we're on the plus. Now we're on the ink. Oh, there's the range. Look at that. And then map ink. Oh, interesting. It shows like
That's really
Oh
cool.
yeah, it highlights it.
What the green highlight is like what it's currently showing you over here.
Yeah, that's really nice.
Map ink. So everyone's one number higher, and the reduce plus 55. Oh, and that's it. You can go back. That's fun.
Yeah, I'm not sure what it is, but that just seems a lot cleaner and nicer to my mind than the typical debugger where you see the line, you're going by line and then you've got a table somewhere that you just have to go look up the current context, what's in the world here, right?
Yeah.
Yeah, I agree. I wonder. Okay. So ClojureScript, we're just gonna go past that because we're not doing ClojureScript. Starting the debugger, local, remote, instrument the code. Code instrumentation is done by rewriting your code in a way that doesn't change its behavior when executed, but it will trace everything the code is doing. You can instrument it from the browser tool. Oh, the browser tool. Ah. All kinds of stuff. User. Clojure walk. Instrument. Wow. You can just attach it to that. Okay, I guess we'll go back and look at here. Instrument from the REPL. You can instrument any top level form by writing trace before it like this, and then evaluating the form. Trace is meant to be used with forms that don't run immediately, like defen. Use rtrace to trace and run a form. Rtrace is useful in two situations. First, when tracing, instrumenting and running a simple form of the REPL like this. Second, when you want to run a form with a certain flow ID. Rtrace by default will instrument and run the flow ID 0, but you can use trace 0, 1, 2, 3, 4, and 5. Let's see. Let's trace 3. Control flow 3. Cool. Of course, it's the same form in both of them, but conditional tracing. Sometimes you need to debug a function that is being constantly called many times per second, like in a game loop. Adding trace will make too many traces, and everything will get slow. In most cases, you probably don't want to trace absolutely everything, but you are probably interested in execution under certain conditions. This is what ctrace is for. Ctrace is exactly like trace, but the difference is you control when the tracing will be denied, enabled by the use of a trace.
Oh, whoa.
Where's the when meta? Oh, here.
Yeah, right there.
Really? That's pretty cool. Oh. I don't have a called many time function to call. Called many times. Weird to be doing this at the REPL, but we'll go with it. Sure, let's do that. So I'll paste the whole bit in here. What happened? What happened? Oh, maybe I got to call foo. There it is. Huh. It's interesting. I don't know if it's hung or something. Let's see, instrument namespaces. You can instrument enter namespaces by adding flowstorm instrument forms for namespaces. The first argument is a set of prefixes to instrument. All the namespaces starting with this and starting with CLJS. Second argument is a map supporting which ones to exclude, disable, verbose. Gotcha. Okay, I feel like, oh, instrument with the browser. You can navigate to the bar you're interested in and use the instrument button to instrument it. Using the browser, you can instrument multiple namespaces. Do this by selecting namespaces you're interested in, and right-click should show you a menu with instrumentation commands. I wonder if we should instrument something like Clojure core Inc. Oh, core's big. Oh, I gotta do it on the right here. Inc. 1. I didn't change any of the flows over here. I don't know. Any thoughts? Anything I might be missing? Are you all still with me?
I'm still with you. Sorry, I'm not sure.
Yeah. Okay. Cool. Yeah, it's interesting. You can uninstrument code. The bottom panel shows the instrumented stuff. Oh, here you go. Okay. Fully instrument. Okay, so, oh, here they go. Flows tool. The flows tab contains a bunch of tools for analyzing all traced execution flows. Flows are identified by a flow ID and can be run. You start by running a form with rtrace in those. If you run a flow with the same ID, the first one is going to be replaced. A flow can happen in one or more threads. A separate tab will be shown for each thread.
Oh, whoa.
Yeah, there's the good stuff. Oop, Stack Overflow. Uh-oh, I think did I break it? Yeah, this should be just running 5 parallel ones, so it shouldn't do. Huh. Okay, let me restart. Oh, look at all the errors over here. Okay, I'm just gonna start again. Debug the debugger here. Okay. That's what I want to do. Back here. Start this up again. Acquire. And the remote. Come on. Remote connection. Okay, got that one working. Now let's do our trace PMAP again. Hey, there we go. Cool. So thread 1 is where it started from, and then it spawned 5 other threads, huh?
Yeah.
Let me see. What is it saying? There'll be 1 thread for each of the PMAP forms. So there's 5 threads should be thrown, and probably 1 thread for each. Oh, there'll be 1 thread for the top level form, and then 1 for each of the function calls here. Since core PMAP is backed by a thread pool, it can happen that less than 5 threads are shown, in which case they will accumulate inside the same thread tab. Oh, interesting. Anything instrumented that isn't run under rtrace will end up in the funnel flow, which accumulates all traces that don't contain a flow ID. Oh, that was what showed up before, was like a funnel. Okay. Interesting. So if it's got a flow ID, so like rtrace, it's flow 0. So flow this one, I is 0. And if I step this one, I is 1. And this one, I is 2. So this is each of the different invocations.
What would cause something to be instrumented that didn't have a flow ID? I guess that's what's confusing me.
Yeah, me too. I figure well, let me do that. See, it's def called many times. And then if I do this is what made that thing come up before. Conditional tracing. We'll either find out or we'll break it again. So if we paste that, and we call foo. So maybe the C trace means it doesn't. Let's see if there's oh, we got errors now. Can we figure out what? Yeah, I don't know if I can tell in there which evaluation caused the error.
Oh.
Ooh, look at that. I did an R trace again, the P map, and there are only 3 threads. There's I is 0. I is 3. And it results in 9. 2 and 4. I guess it overwrote it then. Maybe so. It's very interesting. Oh, no, they're both of them here. So this one has, look, this one has 10 steps and this one has 10 steps, but this one only has 5 steps. So this must, if I run this whole thing through, I is 0 and I is 0, multiplying together it's 0. And then it runs it again with I is 3, 3, and 9.
Okay.
So they're just in sequence. It's interesting.
I wonder if the error caused from the C trace thing, I wonder if that's holding on to any of your threads. I mean, maybe not. It could be any other process, I suppose.
Yeah. I mean, it is. I wonder if that would get that same error if I was, because it's remote debugging. So I wonder if there's something that's doesn't, the remote debugging abstraction is leaking a little bit. I'll have to try this again tomorrow when I'm on my Mac at work and try it, because then it'll be the same. But are you on a Mac, Nigel?
I am trying to update Java.
Oh, that might be an old version you're conflicting with or something.
Yeah. I think that's what's causing. I think that was the issue I was getting when trying to run remote or local debugger, is through like a Java version error. This version of Java runtime only recognizes class files up to versions up to 52.
That's that's the one. Yeah.
Yeah, and I'm watching my Mac Java control panel update tab just spin. So, I was probably long overdue. I need to do that. It's bound to happen at some point.
Yeah. Let's see. Is that where we're on? One thread for each of those things. Anything instrumented. The code tool. The code tool is the first of the flows tab. It has most of the functionality found in a traditional debugger. You can use it to step over any expression, visualize values, locals, and more. The numbers at the end show the current trace ID versus the total trace. Wow, look at that, 890, wow. So I guess it runs the code and then it lets you step through by going back and forth. So I wonder if, I assume there'll be some way to do, oh, it's a tracing debugger. maybe it's not a breakpoint debugger. I don't know if that's true or not, but I'm remembering at the very top it said it's a tracing debugger.
Can it do breakpoints?
Hmm?
I'm wondering if it can do breakpoints.
Well, there's no break in this file, so. Yeah, so you can, I mean, you can still step through, and so you can just stop.
Yeah.
Yeah.
Yeah. So like you would run the code, any side effects are going to happen, right, in the real world, but then you can just kind of replay what happened and see the values at each point.
Yeah.
Okay.
Yeah, I gotta try putting this on something that does like a bunch of like in a web handler or something, and see just the depth that it goes to. So let's see, write any number in the text box to jump to that position. Oh, cool. When jumping around, you can write down any interesting positions you find and use the text box to jump back if you want. So like if I want to go back to 2, okay. No, that's not going to put a bad number in there. Very beginning. I think this is a really cool, I mean, I forget which one of you said it, but like the showing what value, like highlighting it in green is I think a very good user metaphor. Very cool.
Yeah.
Let's see, the code allows you to step and travel through time in 2 ways. You can use the controls at the top to move 1 step at a time, or you can click the highlighted forms to position the debugger at that point in time. You can click on the highlighted forms. Oh, I see. So it lets you jump. To any point. At least the first time that form is called. In this case, that form right there was called twice. Oh, I noticed that the look that's down here, the I3. So it shows you what I is and how you get to 9. That's cool. Only the forms that were executed at least once flow and the thread will be highlighted. When clicking the highlighted form, 2 things can happen. If the form is executed only once, the debugger will immediately jump to it. If it was executed multiple times, a context menu will show all the values that form evaluated to, sorted by time. It's not showing me a menu. It's useful for debugging loops. Yeah, that's really cool because you can click on it and say what values did it have over time. Let's say you just run an instrumented piece of code and an exception bubbled up. One thing you can do is locate the source of the exception is to click the last trace button. It will move the debugger to the last trace capture for the thread, which almost always points to the expression evaluated before the exception was thrown. That's cool. The locals panel, that's what this is. Oh. I bet that's more interesting if you're using a right-clicking on it will show a menu where you can define with a name so you can use it at the REPL or inspect the value with the value inspector. Yeah. Value inspectors. Value inspectors are shown in many places in Flowstorm. Value inspector in the code tool always display a preview of the current expression. You can configure the print level and print meta for the pretty printing by using the controls at the top. Oh, nice. Okay. So I'm going to do something that's a little more interesting. What would be more interesting? That's a little more interesting. Oh, long range. Interesting. Def of R with the name in Clojure under the user namespace and under the JS namespace. We can say, nice. That's cool. I remember when we did the we did a meetup about Portal, and in Portal, it was really whatever you had highlighted, you could really easily get it back in your REPL by just dereferring the atom that is the handle or whatever for Portal. And so it seems like a similar facility, which is very cool. Persistent vector. Yeah, that's very interesting. Any thoughts, guys?
I wonder, I'm not just thinking like, one of the things I bet this would be helpful with is like functions that have like anonymous or like Lambda functions within them. Sometimes that's like when I look at stack traces, that's oftentimes like the most infuriating thing to try to jump down. It's like something broke in this anonymous function. If there's like a line number, then that helps, but to see it pop up, like if you were in a named function and then you jump into one of the sort of like intermediate, like anonymous functions that something's putting together, just to then see that function maybe pop up in the trace, I think would be helpful. Because like that was something I was working on the other week, where it's like, oh, there's like a bunch of anonymous functions. Like, oh, which one is this?
Right. You get lost in the stack trees because it's all a bunch of there's no names for them all. Yeah, I wonder if this would help with the quintessential Clojure problem of what is this map? What keys does this map have in the middle of this, you know, series of functions I'm calling on it?
Oh yeah.
We don't have types, so at the fourth level, what does it look like here? And so you have to usually put in like a due to println or something. But I would assume that you can do, like if you do range 10, and you get a map inc, and then filter odd, right? Odd, of course.
Question. Yeah.
So if we do like this, or trace 2, can we see what it is at each level? So you see the range 10, and then you see that it's that format. So at each level, yeah. So if you had like five, you were doing 5 different transforms, you would be able to see it at each level what it looks like, without having to actually put any debugging, any printlns in there. So I think that's that would definitely be useful for me. In fact, I tend to design in my code so I don't do those threads because it's easy to get lost. But sometimes I encounter code that wasn't designed with that, and you're 4 or 10 call levels deep, and you're lost in the dynamicism of Clojure, and you wish you were working in a typed language again, just for a moment, not forever, just.
Tyson, quick question. Have you ever had issues with upgrading Java on a Mac?
I have. I mean, most times. So I'm not using Java currently at work, right? So each time I have the meetup, I'm not using Clojure either, unfortunately. So each time we have a meetup and I'm trying to like get the thing to run, I always have these JVM issues.
Great.
So that's why this time I will just watch and try to absorb rather, because it's usually like we're at the end of the tutorial and I'm like, I've got a REPL.
Oh man. Yeah, no, the issue, like I got a REPL and like Clojure or CLI works, and I'm on like Java 8. The issue that I get is this like class issue thing. Let me see if I can make it happen again. Where it says, I shout it out once it happens again. Wait a sec. But it was like, oh wait, here we go.
You would like to share? We can.
I could just. Oh yeah, I mean, yeah, sure. Let me. Why not? Let's rock and roll.
I've debugged enough on my side.
Okay, so this is. Everyone read that. So like, yeah. Open up the CLJ, deps, all that, require it, then try to call local connect and get this class version 55.0. This version of Java runtime only recognizes classes versions up to 52. Oh, 55. So 55 is Java 11. So I need Java 11. Does that make sense?
Okay. Yeah. Oh, okay, good. That's what I was wondering. Which version is 55? Because I got 11. I lucked out with 11. I happen to have Java 11 on my Windows computer, which was like I'd never installed it, so it was lucky enough to get that there.
This is the other confusing thing here. It's this Java version thing. Does anyone know what that number means? Because this thing
right so that's version 8.
Okay. Which makes sense because if I go to about, version 8. Okay, mystery solved. I need 11, which will take as long as this takes.
What are you using to manage your Java version?
Just the Mac Java control panel, which is this. I'm open to suggestions on how to improve that. I could maybe try some other runtime version.
I for a long time I was using Brew to manage my Java versions, but a coworker turned me on to ASDF, and ASDF seems like it's like a version manager for, you can manage Ruby with it, or Python, or Line, or Clojure itself, or Java, or I actually managed Haskell with it too because I needed something that was written in Haskell. And it's pretty lightweight, and so I've been switching over more things to using that rather than Brew for like all the like utilities that I want. But if it's a runtime, I'll use ASDF because it's a little easier to switch between them.
Yeah.
The other idea is to brew Cascade. Yeah, I mean, there's like, and then there's also like specific Java version managers like RVN for Ruby. It's like there's one for Java. I forget what it's called, Jams or something. Anyway.
Oh. I'll check out ASDF.
Yeah, definitely check it out. Yeah, you basically the way you install it is you clone it into your root or your home directory in a .asdf folder, and you add initializer, and then everything else is from there on. It all just works. Like there's no other install.
Cool. You can take back the screen. This might take a while, and this is not particularly fun. How do I give you back?
But it's always fun to geek out a little bit.
Here we go. Stop share.
How do I shut? Yes, that should be
Thanks,
like
guys.
it's a game. How long does it take you to stop screen sharing in Zoom?
Yeah, it's like on top of dark windows. I don't. It's usually on top of like a white Chrome browser, and I can find it.
Usually, yeah. What I've been doing on the Mac, my other like thing that has saved my sanity is on the Mac. There's a status bar icon for Zoom, and so anytime I want to do anything with the Zoom controls, I just use that menu instead because I always know where it is, and so that's much easier to find the stop button, even though the menu is horrendously organized. At least it's all in the same place. Okay, let's see. What do we got here?
So one thing I just thought would be interesting is to see stack in a recursive branching like function, like why can't I think of a good one, like factorial or something like that. Let me see if I can pull up.
Yeah, I think I know what you mean. Like a recursive function.
Yeah, and it's specifically one that sort of branches out. Think of a good example.
Do you happen to have one on your screen there?
That's what I'm gonna look. I probably have like a scheme one from my SIGP notes, but maybe like a simple Clojure factorial.
Let's see if while you're looking for that, I'm gonna see if I can instrument ink again. Figured it didn't work the way I thought it was going to, so I'm just gonna try. And there it is. Instrument it. Okay. It didn't really show up. Let me try restarting it and see if it's a result of the errors that I got before. Let me just try that. Let me know when you got something, Nigel.
I just chatted something.
Cool. Let me just.
Although I think I might have written that wrong. Do you want to recur? No, let me just culture.
Oh, in the chat.
Oh, you know, yeah, sorry, it's in chat. I could put it in there.
So then this would be a trace, I'm guessing. Oops. Let's see, let's go import, not import. require. Reads all the bytecode, compiles it all, layers of value. Come on. Let's take a little longer. There we go. Connect. I'm just gonna do 3. Make sure I can do 1. Okay, cool. Okay, now I'll do the trace. This thing. So if I call length, so I guess if you did, because I called it and didn't give it a number, that's why it showed up in this bucket, the pipeline bucket here. Let's see if I can step through it though. Oh, there you go, 95 traces. It's like there's a bit of a issue with the code formatting here.
Oh yeah,
So
maybe.
Collection. If it's empty, no. Then get the collection, call rest on it, which is without the 0.
Oh yeah, it's got a bottom out.
Oh, and it calls itself. That's why. I was like, there's this 6, and I'm like, what's it calling? It's no. So now it's collection. Click on empty collection. False. Rest without the 1. Okay. Without the 3. Almost there.
And
Collection is just 9, not empty. Rest. Now get that. Is it empty? True. 0. Interesting. I don't know. Yeah. Oh, is it bubbling up?
Yeah.
Because I hit that,
yeah,
that bottom, and now it's yeah. I see. That's why the outer one is running now.
Yeah. Now putting everything back together.
It's doing the plus because it ran length. Gotcha. I see what you mean.
So yeah, so this is interesting. Like it shows just how like slow a naive recursive implementation of that is. That's kind of cool. This would be cool to do. Like I've been working slowly through SICP, and this would have been helpful for some of those. Like there's some examples of like recursive functions versus like iterative versions of the same ones. Yeah, that'd be really cool to see. Yeah. Yeah, that one didn't really branch, so I might maybe I can think of a better one that has like a wide branching factor, but
so then it returns 0, and that's what this is. It's finally hitting this outside, which is the return from the function, and now that's the actual function. Now it returns 0, which hits now it's going to add the 1, which is right there, and now it's returning out of the function. Okay, so I think part of it's like interpreting what the expanding parentheses is like where you are in the function. When it hits the top of the function, that's when you're actually returning. It's very clever. I like it. Not clever. It's easy to understand.
Yeah.
Yeah, it's interesting because it's hard to like come up with Like I have non-trivial code at my fingertips every day, all day, but it's hard to come up with something that's not, you know, oh, I'm going to bring my whole application into this, you know, to try it out. That was, but that's a good, yeah, a recursive algorithm. And then, yeah, it does show that you're using all that processing just to count the number of things. I mean, obviously in this case, it's. Ooh, here we go. The call stack tree tool is the second one of the flow on the flows tab. It allows you to see the execution flow by expanding the call tree. Oh, let's see. Oh, look at that. You can see the argument. The
There we go. That is cool. And then yeah, it goes all the way out.
Level. You can say print level 10. Does that work? Oh, I don't know. Maybe, yeah. Sorry, what were you saying?
No, that is cool. Like that's kind of. Oh, let me see if I can find a good branching recursive.
Oh, and you can see what the args are on the left and the return value is on the right. Huh. And these, I'm guessing, have, oh, yeah, def and inspect. So you can just, everywhere you see a value, you can inspect it, which is cool. There we go. You can use key commands left and right to zoom down your stack trace. And that's if there was like a, okay, now I want to print this for a slide that I'm making for as an example. Were you thinking about a different kind of example, Nigel?
Yeah, I'm gonna see if I can try to find one. Yeah, I want to. What I'm thinking of is something that like needs to traverse like a tree data structure recursively, just see what that does. Let's see if I can.
Like a Clojure walk would be interesting to see. The image here on the tutorial or the guide looks like it has some interesting, like more information. It shows you where you are, like what source files you're in. This one doesn't have that because it's just, you know, in the REPL. But I think this is good. This would be really cool to invest, to be to run, like instrument at the top level of a tree of code, and then run some operation, and then use this to figure out where it branches and stuff, as a way of exploring code, which is something that I'm doing a decent amount right now. And see the return values. Yeah, that definitely is a pretty cool, especially being able to inspect each of the arguments. Because sometimes we're like calling a function and passing it like 4 maps, and it's like, well, that's a whole bunch of data. I don't know what's going on. If Flowstorm keeps receiving traces for the thread while you're analyzing, it will keep rebuilding the tree, but not automatically refresh. So you have to use the refresh button. Okay, that makes sense. There are also 2 value inspectors at the bottom that show the arguments and the return value. Yes. You can search the function names and a string serialization of the arguments using the search tool at the top. So kind of look for like 9. I guess that's almost all of them. Yeah. Oh, no, that. Oh, never mind. I think it probably make more sense if you're actually inspecting a real stack trace. Functions tool is the third one in the flows tab. Let me know if you have something for me, Nigel. I'm just reading.
Yeah, keep good.
The flows tab shows a list of all trace functions sorted by how many times they've been called. Oh, I mean, this is not going to be terribly interesting, this one, but what about this? Print args 1, 2, 3, 4, 5, 6, 7, 8, 9. I wonder. Anyway, but this is all the times that it was called. Wonder if you. Interesting. You still have the step back, forth, and back, like you have the stepping control still, but it doesn't seem like it changes it much. Go to 10. Oh, okay. So whatever execution that you want to look at, you can right click and say go to that in the.
Oh, cool.
You can proceed from it. Okay. Seems reasonable. So the third tab shows how many times it's been called. And I don't think this had a number. But there's only one function. Normal functions will be colored black, multi-methods magenta, types records are green. Oh, nice. Together with the call stack tray, they provide a high-level overview of the flow thread execution and allow you to jump through time much quicker than single stepping. You can also search over the functions by using the bar at the top. Yeah. Double-clicking on any function will display all function calls on the right sorted by time. Each line will show the argument vector for each call, and you can check boxes to hide some of them. Double-clicking on any item on the list, we'll move the debugger to that specific point in time, so you can double-click too. Nice. And then we got the browser tool, allows you to navigate namespaces and vars and instrument and uninstrument them. Taps tool, use taps to visualize your taps. Tap. Taps. Okay. That's totally what I expected it to do. Every time you local connect or remote connect, it will add a tap. So whenever you tap something, it will show in the taps list. It will click on any value to do the value inspector. Use the clear button to clear the list. Okay, cool. This is kind of like a version of not the portal, but or like portal or reveal. You can. Those are both a little more capable, but it's nice to have that functionality here too. Value inspector allows you to lazily and recursively navigate your data. It will render collections with links that allow you to dig deeper into the data. Now I wish I had like a, like a JSON file I could just slurp in or something. Top bar provides a way of navigating back. Okay, let's try that. Maybe this is not deep enough to try that. Come on, you. Let's try something that's got tap. Is 1, 2, 3. Bar is another map with as. Let's close them all back up. Okay. Ooh. Ah, there we go. So you just click on it and it jumps into that value. Nice. It's a decent UI for inspecting data. Although you probably can get lost if you go too far. I like how it automatically makes maps this way. Yeah, that's pretty cool. Let's see, use top bar, navigating back, def button to define a value. The value inspector uses datafy under the hood. Ooh, okay, so this means we can do like Java JDBC.next or whatever and surf through database data. Debug command line programs. If you run any Clojure programs from the command line using -x, dem, etc., you can use the CLI run as a trampoline, start a debugger, instrument everything you're interested in, and then run the original command. Wow. ClojureScript. So you're running your script. Then you would run and debug an execution of the same command like this. So you add the deps. Here's your config to what namespace is the instrument. Which one's not to use? Wow. Oh, cool. -x. I wonder if this works with a, if you can do this with like an AOT compiled jar, or if you need the Clojure source. I'm guessing you probably need the Clojure source. Like not an Uber jar.
So it's finally working for me. Slow storm debugger.
Hey. Cool. Looks like we're actually at the end of the they're styling and theming, but then we're at the end of the manual here. So I'm going to stop sharing.
Do you mind if I share for a second?
Yeah, go for it.
Okay, cool. So I instrumented. Oh wait, let me share. There we go. I have this simple walk call here. Apply max lambda on the nodes, and then the outer form is second. So just applying that, which of course. second would be, anyway, sorry. So I'm stepping through this and it's weird. I'm not like seeing everything I thought I would see. So, so first thread, we're calling second. This third step, we jump in. We're calling the anonymous function. What are we doing here?
It's somewhere.
So yeah, that's like, then I lose it where we are, and then I guess wait. Oh, that's weird. Anyway, they were calling max. Then on 246. Yeah.
Oh, that's the second one of each one.
Yeah. So that makes, oh, okay. And then we get the max of that. Right. Which makes sense. How do we get so this is the tree browser right here?
Yeah.
Is that what this is?
That one is, yeah. It looks like it only has like one, it's effectively one, because it basically figures out that it needs to do, it runs second on everything, and then it runs the function, and then it's done. Like, there's not a lot.
There's not a lot here.
It's interesting.
Yeah.
That first thing, flow storm running.
Yeah. And then it just goes user defined function, which is that, yeah, which is just applying max to it. Huh.
I don't know that I've ever used walk. Huh. I usually use
I just
post walk.
Okay.
So what does walk do?
Traverses a form, arbitrary data structure, inner and outer are functions. So this is our inner function, right? Calling the second on each of the forms, and then the outer function is calling max.
Oh, interesting. So it's kind of like a map reduce
of a data structure. Yeah. So what I was is like call you like in the debugger seeing calls like second 1, 2, second 4, second 5, 6, and then that's but really what's do this again, sorry.
Well, this code is instrumented, but the walk code is not instrumented.
Yes.
So I wonder if you go to the browser on your debugger window and instrument everything in the walk namespace and try it again, if it'll show more. You know what I mean?
Clojure.
Yeah.
Yeah. Where you get Clojure.walk. Can I? Wish I could search. Oh yeah, I can. It's just tiny. Okay, cool. Thank you. And I want, yeah, we'll just cool.
Yeah. Okay. Now see if now we do that same R trace again, if it gives us more.
Oh, interesting. Okay.
Hello.
Oh yeah, this is, yeah. There we go. Oh, this is awesome. Yeah. Oh, this is super cool. I can learn how it actually works. Sequence form, true. Then we call it inner. Says run through this until I see.
Wow, look at the number of traces. It's 594.
Yeah. It's crazy.
Here we go. Now we're making.
Okay, here we go. This is what I was looking for. Calling the bit, like, yeah, calling second.
On all of those things.
Yeah.
And then it calls.
What?
Ooh.
Wait, Max, on this. Oh, weird. I don't know what this is.
Look at that. It's like there's Flowstorm Tracer, Trace Expert. I feel like we've started tracing the tracer or something like that. Like I feel like we've crossed the meta boundary.
Oh, I wonder. Yeah. Oh wait, you know what? Because I called rtrace. Here, that's my fault. I've traced walk. I should just call walk, and then, you know what?
Oh, yeah.
There we go. This might be less insane.
Oh, form. There you go. That's form right there.
Yeah. Cool. Okay, now, okay, yeah. Yep. Now, there you go. Thank you. This is what I wanted to see at each of those steps. The actual data. Cool. So step through.
And there's only 22 steps. That makes a lot more sense.
Yeah, and
3,
then
4, 6.
yeah, which is what we want. And then oh, okay. Oh, that's interesting. Is the intermediate? It's the list, but then puts it back into a vector.
Into empty form. Interesting. I see that a lot. I've never actually used it myself. The whole into empty whatever it is that way, because then if it starts off as a set, it becomes a set. You know, same kind of thing.
That's
very cool.
I'm glad I got it working.
Now all we see at this level is
okay. Oh well, that sounded fun. Cool.
But I think that's definitely worth, like, now that I've seen like this stuff, now I want to try it on my code in my application and see how it actually, I mean, I know how most of it works already, but it'd be nice to see. But then use the instrumentation on other people's code or code that was written before me, that was put that way, that I'm now maintaining. That'll help. Cool. All right, I think we are past the end of time now. Any last thoughts?
No, thanks for showing this.
Yeah, thank you both. That was a lot of fun.